Hello, my name is Zoid, aka Crypto Mux. If you know me by Crypto Mux, you've obviously seen my other channels, Crypto Mux. So I've got other channels in relation to bug bounties and also hacking in general, red teaming, things like this. But I go by the name Zoid on Twitter. Anyway, let's get started with this lesson. So this lesson we're going to talk about reverse proxy misconfigurations and how we can exploit these misconfigurations. But before we dive into this, we want to talk about the differences between proxy servers and reverse proxy servers. So in general, a proxy server, say for example, google.com is blocked in our country. If you use a proxy server, google.com doesn't know who the clients are, because the clients have to go through the proxy server to google.com to access the website. And generally, if you go through a proxy server, if a website's blocked, we can access it. The reason why this is useful for bypassing blocked websites is because if we didn't go through a proxy server, google.com would know what the client is. It would know what the client is, and it would know that it's from our country. So if we go through a proxy server from another country, google.com doesn't know who the client is. It knows what the proxy server is, and we can access that website because proxy server may be from a different country and things like that. It is different than a VPN, but its site is similar, but way different when you think of how it works. But that's basically a proxy server at a very low technical example. Google.com doesn't know who the client is, but it knows what the proxy server is. That's very low explanation. But what is a proxy server? Reverse proxy server, sorry. Ignore all this here because this is where we're going to explain some misconfigurations, how we can exploit it. But yes, a reverse proxy is the complete opposite. The client doesn't know what Google is, or the client doesn't know what any of these internal servers are, or public servers. The proxy server, the internal server google.com, or then google.com, doesn't know who the client is. See what I mean? It's the complete opposite. So for instance, reverse proxy, how this would work is behind Google, there would be a public app. There'd be a lot of different public apps. There'd be a lot of different internal APIs and things like that. So that in order for the client to access a public app, it needs to go through Google's reverse proxy to access that public app. And with all these internal servers, the client can't access the internal server because google.com or the reverse proxy won't allow the client to access any of these internal servers. If it does, then that's a misconfiguration by itself. But if we can access public app and we know there's a reverse proxy in place, how can we access any of these internal servers? Let's talk about this. So say we've got this endpoint that's public to the user, to the client, called /v1/API get tokens. And the get tokens may retrieve a list of like public tokens of some sort. I don't know, anything. Could retrieve anything in general. So what we want to do, if we want to just we start off by just traversing back one directory. Now we can't do this to like every sort of path. It's generally some API paths. Generally the paths have to have some supplied user input. We need to be able to input. So generally in this get tokens, there may be like some sort of ID here that we can input anything. You know, there's kind of like an input here. Or it might be like, I don't know. But you know, what we'll do is we'll traverse back one directory like that. If you want to try, this may just not be this may not even give us any response, but it might just get us a different response. But we want to try different like different path traversal techniques. You might try ... That might give us a 403. It might be blocked. We might type in %2e, %2e, %2f, which is a ... but in Euro encoded. This may be blocked. It might be a 403. So we might try different path traversal techniques and discover that ... gives us a 404, meaning hey, we found out a type of traversal that isn't filtered or isn't like that the server allows. I probably forgot to filter that out. So what we want to do is we want to go back many directories. We want to go back as many as we can, like this much. Say this much. If we get a 400 bad request, it means we may be hitting an internal doc API. We may be going through some reverse proxy. Not the internal doc root API yet. We haven't hit that quite yet, but we are going through some reverse proxy, maybe. So oftentimes it tells us what the reverse proxy is in the response headers. But say this 400 bad request is presented to us. What do we do from there? Well, we might just try going back one more. And if we get obviously type in some random character. And if we get a 404, beautiful, we've hit the internal duck API. But this is not validated. This may not be a reverse proxy issue, because what we need to do is we need to compare this path. We need to compare this and see if this is different to the very start of it, the very root of this current domain, in public domain. If this is different, a different response to this, to that, then yes, there is a reverse proxy in place. That's how we can identify there's a reverse proxy. So if we can get this far, let's try and find out what we can access internally. So this is when we will trick the reverse proxy in accessing an internal API of some sort. For example, say behind the Google's reverse proxy, there is an internal REST API and the endpoint is /v1/admin. We don't know this because we may be able to guess it. We may not be able to know it. We may not actually know that this has the internal endpoint is a REST API. So what do we need to do? We need to fuzz. So we'll fuzz here, and we can use ffuzz, we can use dir search, we can use, well actually ffuzz, we can use many fuzzes, wfuzz, whatever. And then we may, in our word list, it may contain this internal REST API like this. We may fuzz it and we may get this here. And then we may get either a 302 redirect or a 200 OK, meaning yes, this endpoint is accessible by the user. Meaning what we've done is we've completely exploited this misconfiguration. Instead of accessing the public app, we've tricked the reverse proxy and accessing some internal REST API. And we've done this and we get either like a 302 or 200, and we access internal REST API. Boom. We exploited a misconfiguration, also known as secondary context part reversal. But this is not as easy as it seems, because in some cases you might be lucky and you might just be able to guess the internal endpoint. Most times it's a lot harder. So let's see what we can do there. So what we want to do is we want to fuzz at multiple levels. So we want to fuzz recursively, because we might find /v1. Let's focus on this again as an example of the internal REST API here in this diagram. You might fuzz /v1 like that, but we may get a 404 back. And the response codes can trick us. The response codes can trick us on believing it exists or not. So we might get a 304 back if we /v1. Even if it exists, we might get an error, a different error. So don't rely on this response codes. But then we may type in, okay, let's try admin, and we get a 302 or 200 bad request, 200 okay. I keep on saying 200 bad requests. Sorry about that. It's very incorrect. We might get a 200 okay, and then we've successfully exploited a secondary context part reversal vulnerability. So yeah, that's pretty much it. And where do we find these endpoints? Well, that's a good question if you're asking yourself that, because as a hacker, we want to ask ourselves many of these questions so we can check them off on our list. It's good practice. We would find these endpoints. Well, we can find them through, I don't know, REST API documentations. We might look up REST API documentation. We might type in like search, and it may come up with 301, and you might find that's a Microsoft, API or something. Sometimes we might look through JavaScript and find lots of different endpoints, and maybe find some internal ones we can discover on the web app to basically trick it to access those internal endpoints. You might find some internal endpoints, you won't believe it, but in CSS files. You can find some internal endpoints in CSS files. You might do GitHub Dorking, all these different sources out there, we can find internal endpoints. That's generally secondary context part reversal. But yeah, so let's have a look before we dive into some example of misconfigured Nginx proxy rules or versus proxy policies. Let's have a look at how Burp works. So Burp itself is a proxy server. What happens is you got Burp open. You got the Burp is the interception proxy. What happens is if a attacker wants to visit google.com, it has to pass through the Burp proxy first in order to access the website. Then you get a response back. It goes through the Burp proxy back to the attacker. Anyway, you probably all know that. Let's move on to some misconfigurations in Nginx. This first one is that this one here. So let's have a look at this one. Nginx is a web server which can also be used as a reverse proxy, load balancer, mail proxy, and HTTP cache. The Nginx alias directive defines a replacement for the specified location. For example, the following configuration. Say we want to request top.gif. The file then goes to the data /w3/images and will be sent back to the user and displayed. But what happens if this location, this /i, doesn't contain the separator, the / separator? Well, then it's vulnerable. And we can then retrieve files on the file system, also known as a partial vulnerability or attack. These, believe it or not, are found always in the wild because many developers sometimes may not have the skills to prevent this, may not know much about security, and just might have time constraints to get things done by. So leaving out that / cut, it can be quite easy to do. So that's another way to that we can abuse reverse proxies with a partial reversal to access other files on the server. But notice that this is way different than this. A secondary context partial reversal, we're trying to access an internal endpoint, but just a normal partial reversal will access internal files. That's just a different partial reversal by itself. Like it says, secondary context, it's a different type of partial reversal. And how to fix this? We find all Nginx aliases directives and make sure that the parent prefix location ends with a directory separator, like it is an example here. There is many more misconfigured Nginx proxy rules that we can find, and there's many sources out there. Worth having a look online for some of them to play around with, and even set up your own misconfigured Nginx server. You can do it in a virtual machine or VPS and play around with yourself. There's a lot of misconfiguration examples you can play around with yourself. Yeah, and that's pretty much it with this type of vulnerability. I did want to dive deep into how this all works behind the scenes, but one thing to really look at is Sam Curry's blog post on hacking Starbucks and accessing nearly 100 million customer records. With this, the reverse proxy contained, let's have a look. It contained I think a Microsoft API in the back end. Let's have a look. We'll go through the start. We'll have a look at what this actually is. It had a Microsoft Graph instance in the back end that he could then access all the internal users' accounts just by doing this second context partial reversal attack. How he did this, he found this this post request, and it was a back for front end /proxy /orchestra /get user, and retrieved his user information. So like he discovered that BFF actually stands for back end for front end. And this is a demonstration. So back for front end /proxy /endpoint goes through the internal network and then gives back the response. He found that he did fuzzy, and he did a lot of fuzzing with all these special characters and didn't find nothing. He just all returned the same 404 page, meaning probably not vulnerable. It was the same page that you would get when you get a 404 page you would get when there's no page found. But he then crawled, probably looked through his proxy history and found another endpoint that actually had this kind of input here, stream item ID. He fuzzed it again and found that this fuzz here, dot and then / returned a 404, but except this was an JSON response. Not always will the partial reversal vulnerability be in a JSON response. It could be just a normal page. Then he fuzzed back more and more. He come across a barrier where he got a 403 forbidden. The bot was blocking these sort of payloads, so he tried to bypass this by doing just this one here, and he got the 404. Which was good, he bypassed it. And then he went like 7 paths back. Again, this is what we talked about earlier. He got a 400 bad request. So he knows he's too far back, so he went one more path back, so he was 6 paths back. And believe it or not, he obviously he skips the part where he gets a 404, but he typed in search, and he got the 301 moved permanently and moved to the location search. And this means that he's found a reverse proxy issue, and he identified that V1 also existed under search, and beneath V1 was accounts and addresses. So he reached out to his mate, I think his name, Justin, and he said, "Oh, this looks like it, Microsoft Graph API, a Graph instance." And believe it or not, it was. So he played around with some internal endpoints in Microsoft Graph instance and found search V1 accounts, and he's retrieved all his account information. So he played around with like enumerating through everyone's accounts, and believe it or not, he found out that he could enumerate millions of accounts, millions of users' accounts. So it's pretty dangerous. Okay, so what I'm going to do is I'm going to go over what we've learned in a very fluid and systematic way. And we're going to represent this flow in just a simple mind map. Okay, so we find an endpoint. From there onwards, we want to traverse back one directory. Now, if we get a 403, it means there is a WAF. Just by the way, I know it's kind of messy, but and I can't sort of do loops and stuff. So just stick with me. So find an endpoint, traverse back one directory with any payload of your choice. Generally, I do a .. And then if we get a 403, it means there is a WAF, web application firewall, blocking that payload. There onwards, we want to try different payloads until we get a 404. So these are some example payloads. Okay, when we get a 404, we bypass the WAF. If we don't get a 404, and if we've tried every payload, we get a 403, we want to go back up to the first step, find an endpoint. Okay, so if we get a 404, we've bypassed the web application firewall. We then want to use that payload and traverse back one by one until we get a 400 bad request. Then once we get that 400 bad request, then we want to go forward one directory until we get a 404. That means we have potentially found the root API doc. Okay, when we get that 404, we want to compare that same 404 to the root of the domain we're hacking. Example, we find this endpoint here, we traverse back, 3 directories back. Actually made a mistake there, it's meant to be that, just for example. We want to compare the ASDF 404 to the root of the page, and if they're different, they could be the same 404, but if they're different responses, they may contain different headers, different things like that, or one might be HTML and one might be JSON. There may be both HTML, meaning it might not be vulnerable, but if we can clarify or prove that they're totally different in these locations, then there is a reverse proxy. From there onwards, we then want to fuzz for internal endpoints. Now, how do we find internal endpoints? We want to look through JavaScript, look through Cascade styling sheets, documentations, GitHub, or Dorking. When we find, we get a whole bunch of word lists of different internal endpoints for different REST APIs, different internal APIs of some sort. There is even a good website called Wordlists, I think what is it? Wordlists dot, I can't remember, but it's basically, I think it's called wordlists.assetnote.io or something. It's a website made by Shubs, and he owns a subdomain called Wordlist, and he has a whole heap of word lists that he's collected in the past, and put them out there online for everyone to use. So anyway, we found an internal endpoint. We get either a 302 or 200, meaning that we either get a redirect to that internal endpoint, completely confuse the proxy, reverse proxy, and access an internal endpoint. Maybe we get a 302 redirect, maybe we just display it straight away. Then the last step is internal endpoint is accessed. But again, it could be other cases. We may get a 302 or 200 and we're like, oh, we found an internal endpoint, but it may not work. It may just redirect back to the same page as the start of the home page of the website. So therefore, we go from here all the way back up to finding another endpoint that may be vulnerable. And that is the general systematic procedure you need to go by in very, very basic steps. Yeah, so that's pretty much a reverse proxy and some of the misconfigurations that come with it. I hope you liked this video. If you liked this video, please like, comment, and subscribe. It means a lot to me. The support is always greatly appreciated by all you followers and subscribers. And I love the comments. You help me out a lot. You give me some good good advice, good tips, and you make me feel 10 times better throughout the day when you comment a nice, when you comment something nice. It makes me feel really good. So yeah, I haven't made a video for a while, but I'm going to keep on making some of these videos. Although I also check out CBT Nuggets. It explains many things about networking. I've found out a lot of new things on CBT Nuggets that talk about. I've learned so much about networking. It's so cool. Awesome. Well, I'm going to head off. Yep. The subscribe button is down below. I'm waiting. Click it. Click it. Awesome. Thank you for clicking. Thank you for subscribing. Thank you for the support. I will see you in future videos. Bye-bye.